Hello, class. We're going to continue lecturing for stats now in section 2.2. And it's more of the same, except we're going to move on to some more quantitative data and some different opportunities of calculations as well. Nothing, I don't think that's going to be too earth-shattering or complicated, but again, a good introduction, hopefully a lot of a review with regard to being able to organize and display data. So here are the four objectives in this section. And so let's just jump right in to starting with frequency distribution of quantitative data. And so the idea of generating these idea of classes, and this will be, I think of it typically as a range of data. Probably the most classic, and I will show you analysis of that, of classes of data, are grade levels, right? Where 90 to 100 would be a class of an A, 89 to 80 would be a class of a B, and so on and so forth. And so in this arrangement, that you typically go from smallest to largest, but you don't really have to. And what's probably more critical when you do the homework is you want the class widths to be the same. But again, that doesn't occur all the time in the real world, just like in grades, right? Because the failing grade is a bigger width than all the other grades. So that doesn't occur in the real world all the time. But typically when you try to set this up, those are two kinds of rules of thumb that you try to follow, unless you just can't. And so the other thing that is really important is you don't want any overlap. You don't want to say, well, you know, an A would be 90 to 100 and a B would be from 80 to 95. That usually doesn't make any sense. The other thing that's kind of important is typically you don't want to have any gaps. Where if somebody got a 72, for example, and you didn't have a grade assigned to that, then there would be a gap in that as well. So those are kind of those typical ideas. Again, equal width is a goal, but sometimes that just can't happen depending on the real world data that you're taking a look at. So let's set one of these up, again, using the presentation, but you can see here, this is a list of 65 data points of emission levels. And what it's asking you to do is to come up with a frequency distribution. And so you want to figure out how many of the data fits into each one of these classes. And the class width is 1. So the strategy of setting up the class width is you start at 0 and then you go to 1. And then you will go from 1 to 2 and 2 to 3 and so on and so forth. So this one is kind of set up in a nice fashion. And so here's where the classes are setting up. Oh, let me rewind for a sec. You don't want any overlap, right? So you have to pick a cutoff point. And so what the book picked was 0.99 as the cutoff point for the first one. And so you can see how they could be structured. You could also pick 0 to 1, and then the next one would be 1.01 to 2, you know, so you're not stuck in, you know, which one is the perfect one to do, but this is what the book decided to do with the classes and the range with regards to that. So then what do? Well, you go back to the data and you say, well, what fits into that range, right? So 1.5 would be in the second range, 0.87 would be in the first range, and so on and so forth. Not a nice way to do this unless you plugged it into a spreadsheet and sorted it, but just kind of count the number of times that it occurs. And if you did that, this would be the frequency. So remember, if I add this frequency column up, it should add up to the total data set, which in this case is 65. So with regards to relative frequency, exactly the same way that we did it. You do it in this case. What you'll do is you'll take the total number of data points. In this case, it's 65. And here we have it displayed in frequency or in decimal with 3 decimal points. But you would take the first entry of 9 divided by 65, and you would get 0.138. Take the second entry of 26 divided by 65, you get 0.4, and so on and so forth. So this is how you kind of set it up by hand. Let me show you how to do it with the spreadsheet. So with the spreadsheet, here's an example, and as I said, kind of a classic letter grade where we have different test scores. It looks like there's 40 of them, and we're putting them in the classes up to 10. So here we're going from 40 to 49, 50 to 59, et cetera, et cetera. So when we get to this point here, here is our frequency table where the classes, and then you have the frequency. So if you go to the spreadsheet, here we go. You got the spreadsheet, preloaded this in with regards to that. So again, just to remember, the first thing we want to do is we want to make sure that that number adds up to 40. So you go up to function and sum after it's highlighted, and you can see it does add up to 40. So we had 40 test scores. And so that's our data point. And so what do we want to calculate? What do we call relative frequency? Gotcha. So to calculate the relative frequency, let me label that up there. To do that calculation, remember we want to do the total divided by each one of the entries that we have here. So again, to start a formula in a cell, you click on the cell and hit equals. And again, we'll click on that cell to bring the 3 over, and then we want to divide by 40. And so that would be the first relative frequency. And the beauty of this is that if you copy that cell and then highlight all the other places where you want the same formula, and you right click, and here's the paste, which is the first one, paste formulas. And there you go. And what's really nice about it is as you go down here in rows 3, 4, 5, and 6, it'll change the values to 6, 6, 11, so on and so forth. See, if you look up here, you can see the formula up here, and you could, whoops. And you can see it's B5, which is the 11 divided by 40. So again, just another way to kind of illustrate and how to display the data by hand, where you would get a piece of paper and generate it that way, or use the spreadsheet. I would highly recommend using the spreadsheet and start getting familiar with it, because you'll see as we continue on, Alex has a nice function where the data can be directly downloaded to the spreadsheet, and you'll see the calculations just are so much easier because the formulas are set up for you with regards to the calculations. So the next subject matter in this is, again, displaying data. And a histogram is like a bar graph. And so basically, if you kind of take a look at the bar graph, it would look something like this, where you could do it in frequency or you can do it in relative frequency. And again, the bottom here would give you the class from 0, 1, 2, 3, 4, 5, 6, 7. And then here would be the frequency aspect of it as well. So when you generate these things, you do want to make sure that you don't have too few classes or too many, because the data will look kind of strange with regards to that. So one of the reasons why it's nice to have the class width the same is that the bar graphs, the width of each bar graph will also be the same as well, or a histogram when you display it in a graph format like this. And so let me show you, if you go back to the Excel example of the grades of an exam in a stats class, to generate a histogram, you could have Excel pretty much generate another bar graph for you. So you highlight the two columns, you hit insert, and if you look at the recommended charts, here's the cluster column with regards to that, and you can see it generates a nice bar chart with regards to that. Now you can see that this one isn't connected right next to each other, and that is the difference between the histogram and the bar chart, where typically a histogram, they will be connected right next to each other. And in a bar chart, they're typically spread apart. So I'm going to take a little break here and continue in recorded lectures and finish this section in the next